Hello, Professor Sargent here with you again. Going to talk about the multiplication principle and then some special cases called permutations and combinations. Suppose you go to a fancy restaurant and there are, for children, 3 appetizers available, which for lack of imagination, I'm going to call that set of appetizers A1, A2, and A3. And then there are 4 entrees, i.e. main courses available. Again, for lack of imagination, E1, E2, E3, and E4. How many orders are possible? One approach would be to make a tree diagram, which is based on the branching of decisions that are made. So I imagine that the waiter or waitress would go around and first ask about what they want for an entree, and there are 3 choices. And then the decision tree branches again when they come back around and ask what they want for the main course. So there are going to be 4 choices. If the first appetizer has been chosen, there's going to be 4 choices if the second appetizer was chosen. And there are going to be 4 choices if the third appetizer was chosen. If you look at how many endpoints we have to this branching, there are 12 of them. Now, by the way, my preference would be, since this is happening in order, ordering the appetizer first and then the entree, my preference would be to list the different choices as ordered pairs instead of a tree diagram. So what I'm going to show here is all the ways that the first appetizer could have been chosen. Oh. Followed by all the ways that the second appetizer could be chosen. And finally, all the ways that the third appetizer could have been chosen. Either one of these approaches, this may be something that you might have seen when you were very young and your teachers were trying to lead you to multiplication. For example, we see 4 choices here, 4 choices here, 4 choices here, suggesting 4 plus 4 plus 4, or better yet, to get to that 12 more quickly because of the repeated addition, 3 times 4. So what we just saw there was an application of the multiplication principle. If we had also been asked about selecting a dessert, and we knew how many ways there were to do that, then you could consider, first of all, the choosing of the appetizer and entree, put that together as one task, and the choosing of a dessert as another task, so that we would find out how many ways there are to do all 3. Well, instead of thinking of it that way, we can just say that we can generalize the multiplication principle to any number of things that we wish to do, or any number of tasks. So if you have m ways to do a task, and you know how many ways to do each, then multiply how many ways there were to do each to find out how many ways to do all m things. So in a similar question, we're told here that kids can choose just 1 dish, 1 dessert, and 1 drink. There are 5 main dishes, 4 choices, 4 desserts, and 6 drinks available. So by the generalized multiplication principle, we would have 120 different meals possible. In number 10 here, also apply the generalized multiplication principle. We're going to start with a letter, and that letter cannot be A. So that's going to leave us, for the first task, 25 options. And then we need 4 digits. There are 10 digits. However, that 4th digit must be non-zero, so that would leave us 9 choices there. And so that's going to give us 25 times 10 cubed times 9. 25 times 10 cubed, which is 1,000, times 9. 25,000 times 9 is 250,000. I want to say, let's see. I typed it wrong anyway. If I multiply by 10, that would be 250,000. So I suspect 225,000. And that's what I get on the calculator. Okay. Now what next?